So, this is a simple connection of a 4-way of a stick system. They have a glass, then they have a pressure plate, they have a mullion. This is a mullion, vertical, anything vertical as I said is a mullion. This is a transom which connects horizontally. This is a glass, then they have a mechanical pressure plate to hold the glass in place. This is a simple representation of a stick system. So, all this you do at site and then you get the glass and then you put them at site. This is an example of an aluminum extrusion. You can see how these extrusions are. They made to the profile you make the shapes you like and then they come in. So, as I said, they are easy, malleable, corrosion resistant because of the protective coating you do, easy to design and easy to form and finish it. So, you can cut, you can do anything on this. Steel, the next available material is steel, but it is hard to work on. Yes, still people are developing steel systems in different parts of the world, but it is not commonly used structure for a high rise building. So, aluminum is the material which you can use for facades. So, these are the sections. Now, as we saw before, whatever is horizontal we call it the transom, whatever is vertical we call it mullion. Then of course, the bottom of this panel we call it sill and head. So, it is like us, we have a head, a foot you call a sill. Mullion, when you are starting to look at the design, it is more of a simply supported structure from here to here. The column spans like your column here, it spans from the floor here to the floor above. So, the design have to take care of all this design. When you are designing a column, what are the factors you consider? You have to consider the same whatever is required as per the specifications and the requirements by the codes. So, non-visible area which is called spandrel, like you see here, whatever is visible where you can see through is called vision, simple. Whatever is non-visible you call it spandrel. Okay, this is where you can't see through, but you want to contain it, you want to contain something behind, like a slab, like a beam, or all your details. This is where the spandrel panel happens. Of course, behind the spandrel there are a lot of things you can do, where you want to put granite, you stone, metal, whatever, but basically the shadow box acts or the spandrel acts as a media which does not allow the spread, that is number one. Then again you contain whatever you want to contain between floors there, whether it is fire, whether it is heat. So, you contain it in the spandrel zone. This plays a very crucial role. Of course, to get the spandrel to get along with the facade, there are a lot of choices. You can do shadow box, you can put a lot of glass, different types of glasses, stone, metal is a choice of architect. So, talking about gaskets, there are different gaskets like static gaskets, what we call, it means it got a function of static, which is static means you are compressing something and it holds them in position. Dynamic gaskets are something which moves along with the system, they are dynamic because it has to flex, it has to open and close, they have to be dynamic which goes along with the system. So, static, it is completely static, it means it is fixed, they just expand and contract and keep. When you talk about dynamic gasket, say example, I have an openable window, the gasket goes along with it and when it comes it should close back. So, these are the two commonly used names for gaskets. So, dynamic moves along with the system, it opens and closes as per the design requirement. Static is something which is very static, but takes care of compression, elongation as per the design. So, material we saw earlier. See, the gasket was pulled out of the frame to show where it is fit in the real world with the glass. So, it does whatever it has to do. Sealant, we would have seen should have seen this slide along with the double side tape. However, this is a material which has been an invention of 50 years now, I believe. So, it is a byproduct of petrol, and yes, this material keeps any bonding to, they bonds the structures together. They have high tensile and high shear stresses. So, they can be used as a structural sealant, it means holding something structurally to any element, or weather sealant, it means you can seal a joint not to let air or water to go in. So, they call Normally these are the two things they call weather sealant or structural sealant. So, structural sealant is something which holds any form of structure against any member. Like in our case, where what we have done, if you see in the system what we have been designed, say example here we use a structural sealant. We hold the glass into the structure, see here, this is where you use a structural sealant, and this is what you call a weather sealant. It means a normal metal to metal, there will be a small gap where you can use that to seal, weather sealant. So, structural sealant holds a structure against a structure, like in the mullion or transom, wherever you want to glue the glass to, you use a structural sealant which holds them together. Again, you have a different whatever material you see here, I am just going through very briefly, because all this material in specific will be taken care by other colleagues of us, where they will give you complete detail about each product. So, here I am just simply telling you how it goes with the fundamentals of facade, that is all, not going in depth what sealant is made of, how it works, because that will be taken care by our colleagues in depth for you. So, it is much easier. So, sealant commonly these are the two sealant you use, and inside that you have various sealants available, 2 part and 1 part, non-bleeding, non-staining, a lot of things are available, but commonly structural and weather sealant. So, they come in a tube form, or 2 part comes in a container like this. You mix them together like whatever adhesives you see, you have an hardener and you have a base, you mix both of them together, then they start chemically acting within a time frame, and then they get harder and harder as we go on. So, sealant takes care of a lot of things, addition to the substrate. As I said, if you have a mullion, you transform fixing the glass, and also it is rubberized. Okay, the whole system, say example, if I go and put a hard putty to hold the glass like Golden Day, what will happen when the system bends or moves back and forth, they break. But sealant is like rubber, it is rubberized, so they expand and contract. And as well they take care of weather, they seal the joint, so water, air cannot pass through. Yeah, this is application. When you are applying the sealant, you use a cleaner, you clean the glass, then there are a lot of things, IPA solution, alcohol, acetone. So, use those kind of specified cleaners to clean your substrate. Sorry, then only you will be able to do away with the glue. Otherwise, what will happen if your substrate is not clean, then whatever you want to attach to, they will fail. So, there are specified cleaners available. This is called the surface preparation. Whatever surface you want to prepare to glue your glass, you have to do in the recommended way. Then of course, primer. Sometimes you have to apply primer to create a chemical bonding between the substrate and the material. So, you apply the primer on the substrate, and then you apply the sealant and put the glass or any other material. So, what it does, it creates a bonding, a good bonding, and it is advisable to use primers. That will be covered by a sealant manufacturer later. However, these are the principles, when you are manufacturing, these are the principles you adopt. Setting block. Again, this is a form of rubber done out of EPDM. As I said, here the show hardness have to be higher, because the dead weight of the glass have to be transferred back to the frame. Say example, I have a glass in the frame, I have to transfer that weight back to the frame. How I do that? So, I use a setting block. So, setting blocks are kept at 1/3 or 1/4 points and at both sides, then you leave the glass, the dead load will sit onto this EPDM. Without this, what will happen? You go and rest the glass against a metal directly, they will break. Why? Because aluminum goes up and down, they contract, they shrink, and then glass cannot take that. And also there are dissimilar metal and material available, they go through abrasion as well. So, better you have to, is a must to use a separator where it sits rigidly, and you start transferring the load properly into the system. Otherwise, if you start putting without all these things, without setting block, if you put a glass, what will happen? The load will not be distributed equally, and then the things will start cracking and the whole thing will go for a toss. So, setting block design is very critical, and also the hardness. It can be too hard, it can be too soft. It has to be designed with a proper show hardness, so that you will be able to take the load. Packer rod. See, again when you start doing any sealant work, you can't just simply press sealant. It is not properly, it is not viable commercially, plus it will not work because sealant will take time to cure. So, for sealant again they have a calculation which will tell you what is the width and depth ratio. To contain the width and depth, you use a backer rod. Backer rod is nothing other than a spongy foam, where it is a closed cell foam done out of a different polymer, which you press inside the joint. It just is flexible, you press it inside to the required depth, then you start applying the sealant. Then only the sealant also will function properly, as well as the system will function properly. So, these are the key important things which involves in your manufacturing process. Hope I have covered most of the things very briefly and some in detail. Now, how you design a system, what are the key things you consider and how you put them together. This is what we are going to see in the next few slides. Now, when I design a system, what I should consider? These are some of the loads what you have here. Dead load. Dead load is nothing other than its own weight. Wind load, of course, the external force which is acting onto the system. Earthquake load, of course, seismic we call it. Thermal load. Of course, the heat is not going to add weight to the system, but thermal load also adds to the expandability of the system. So, without calculating the thermal load, if you go and design too tight a system, then when the expansion happens, the things will start bulging or burning out. So, these are the key loads you consider while you design a system. Following component system have to be checked for its stability. So, when you say example, all these I am giving an example of a unitized system. So, these are the elements, you check them individually. First what you do, stability of glass under wind load. So, you take a glass and you with the size, and then you check what are the things you check. You check against the wind, what happens to the glass, how much of things is bending, whether it is within the tolerance. What do you call by tolerance? Okay, there are codes of practice. There are a lot of codes available, but for India, yes, today you follow NBC 16 or which is in purview today. So, as per the code, what the code says, what is allowable we call. If a glass has been there for this size, for this terrain, what is the load applied to. So, you calculate it, and if the limit is within the allowable, then your glass is safe, plus your factor load. So, your wind load plus live load plus your factor all put together, and then allowable, what is allowed. So, you calculate that if it is within the allowable considering all this load, then your glass is safe. If not, then you keep on changing the glass until it is safe. Same structural bite and thickness required. We saw the structural sealant. For that also you have a calculation, which is how much, as I said, the double side tape plays a critical role in the sealant size. So, you need to understand the requirement, how that also there is a design derivation for it. So, you design the joint and then you go back to the structural system, which is the mullion, your transom, your head, your sill, everything you design, your openable panels as well. So, you design, you check the system, you check them for all the criterias. What are the criteria? You check for connections as well. When you connect two system, mullion and transom together, your bolting connection, how the screws are done, your bracket connection, your anchors. So, it is not just simply every project I take similarity and go. There is no similarity in projects. Every project is unique. Every project you have to design, every project you have to check. You can't say I have done a building A, so I can cut, copy, paste, I can use it. No, it does not work that way. You calculate, you check properly. It can change, it can help, even though they are same, but different places they can't be same. Different nomenclature, the facade, the logarithm or whatever you call the coursing, the module itself, if it is changed you calculate, but it is better always every project you check all the material, whatever you are putting in you must check as per the code. Say what you see here, example, the glass here in this calculation we have taken as a 4-side supported panel. Yes, you can do 2-sided, you can do single-sided, but I am not going into detail, that will be done by colleagues. Here I am considering a 4-side supported system. So, nowadays you have softwares which are like StatPro, ETAP, Mapla and so on and so forth. You apply all the loads and criterias in the software and you check the design. Like if you see it is 4-sided and you see the images here, they started to tell you how much they bent and they started giving the minimum and maximum values of wherever they bend, and also they give spots. You know the severe spot where the bending happens, the red color one is where the maximum is, the green ones are on the safe zone. So, like this you get the stress check as well. It is like as you go do a ECG. Similarly, in this software ECG for glass is done, which gives you a complete detail of the material before even you can think of designing the system. So, you check the thickness of the glass, size of the glass based on the codes and based on the allowable, then you go to your system design, start looking at them. Now, what you see here is the bite. As I said, the sealant bite here it is shown like 12 millimeter. So, this is a 12 millimeter by 6 millimeter sealant is required all the 4 sides of the panel to hold this glass in place. So, in the system if you see detail, this is a weather sealant, it just do protect water and wind not to go through this gap, and this is a glass material, this is the structural sealant. So, you calculate the size of the structural sealant, that is a formula which is like 0.5 times short span, which is your width, times wind load and then the sealant design strength. So, the bite size you calculate based on the calculation done by the engineers and the recommendation by the sealant supplier, then you design this mullion. Say example, I need a 15 millimeter as per the code, then this mullion design will be governed by this. So, you start from your substrate, do not do the reverse, I have a mullion then I have to shoot, no. You take the module, you talk about the glass and then say example there is a glass as your infill, take that infill and then design it. Then only your system will start to work properly. Say example, I have a fixed mullion and then I want to fit something, it cannot work. Then what will happen? You have to reduce your grid and you do propagation combination to use your system. So, it is not advisable. So, each project you do a calculation to understand the requirement based on the modules, based on size of the panels, then you design a system. So, here I would like to highlight, that is why your off shelf solutions provided are not helpful. Sometimes you overdo, sometimes you try to factor in, that is not right. So, you calculate every project, study deeply, then you take a decision. Now, you check the mullion, see you have done the glass, now you bring it back and apply to the mullion, because mullion is the column which should take care of the load. So, you have a female and a male mullion, then you combine it and you do the analysis. So, you bisect the aluminum mullions and then start understanding how they work by simulating it in a complete form. So, you run through StatPro, commonly used software, you build the model completely with all the factors given, you have the anchorage system, where it is anchored, what is the live load and what, then you run the system. Then you get a complete detail. This is an example shown for a building with floor to floor panels anchored in 2 places, how they react, that is what it is shown here. So, you check the substrate first, check the bite thickness, design your mullion and then you check your mullion. In mullion of course, you check it and it should go with the factors, all the required factors. Most of the time, yes, you check your mullion for slenderness and deflection. The mullion deflects more than the allowable, then the whole thing will collapse or they will start to deform. So, understanding the depth against the wind. and dead load it is very minimal, we do not have to take that as a consideration, but your main criteria will be against the wind. What is the load? Because that factor will be more. Sometimes the dead load can be heavier if you put strong stones or anything, but most of the time when you design it is against the wind. So, so you do the glass or the substrate design first, understand the requirement, seal and bite, then you design your mullion and transoms, and then you run your system check. Like if you see in this 11.6 mm or 11.8 mm is shown as allowable. So, you have to check this against the span. Say example, span by 90, span by 240, span is the span of the panel, and whatever the allowable as a deflection. Say mullion, if they say not more than 20 millimeter, so a deflection should not exceed 20 millimeter. It should be designed in a way it should be below 20 millimeter. So, like in this case the allowable may be like 20 millimeter, but the maximum deflection they are getting is 11.8. So, hence it is safe considering all the factor loads, whatever loads they apply. So, it is like calculating a simple simply supported beam or a column, right. So, run through the program, or even manually also you can do, but people nowadays do not do too much of manual calculation, they always go with the softwares available. This gives you complete detail. So, you start the reverse, the substrate first, then the design of mullion following with the transom and other things. Once you pass through, then you just design your bracket system and anchors. So, what are the bolt sizes you need and what are the loads it is going to take care of. You can see basically what the bracket system what you have should restrain the wind load as well as the dead load. So, like example, these two bolts here they act in shear, but at the same time this bracket here, this bolt will go into shear as well and as well as uplift. So, you have to design a combined combined forces. Sometimes you will see both under tension and compression sometime. So, those sort of things have to be studied properly before even engaging on design. So, you start with the substrate, then you design your glue thickness which is the structural bite thickness, then you design your mullion, you run through the system. So, complete system will be run through, have to be checked properly in a proper way. Yes, now with this I would like to wrap up what we have. You can see some buildings I put in here, they start coming with the various forms. I just collected these images just 2 days ago. You start to see different forms of facade. They are still alive, even these buildings what you see they are like 100 years or these buildings are available still. I just got this small image of Madras in 1940 and now what is Chennai look like. These are all metals, you see these are all free from metal, they are stained aluminum panel, these are free from stainless steel panels. So, different forms, different weaving like this again with the cladded one, this full with glass, whatever you see we have colored glasses. So, where we are heading, what we want to do. So, basically we are standing in invention as well as bridging over from the past and whatever we learned. So, now we need to understand going into future how we are going to act upon to design systems and facade which can take care of the environment, which can take care of our well-being. So, this is where the time is spent now. Yes, we have a lot of ideas, we have gone through various phases of transformation. Now, collectively you have to decide and design systems which can be good for the environment as well as our livelihood, as well as our future. We should not design systems which are not user friendly, which are not giving comfort, rather put more attention towards comfort. Doing too much is not good, too little also not good. So, be active and choose systems, choose material which are viable, which are good, and we have seen throughout the presentation what are the different materials available. The choice is ours. What we want to do, how we want to do is a decision we all have to make, but on the same breath do it right. Do it right, not only just simply considering like this is a design, it has to fit in the building, but also put more effort to understand how I am going to build it, who is going to build it, in what form it is going to get done, how safer I can design it, quality. So, understanding about facade, it can be not just simple like this half an hour or 1 hour or 2 hour briefing, it is too elaborate. However, the basic fundamental idea is to understand the facade. I hope this brief would have given you some insight about the facade and how it has been done.